Okay, so we're picking up where we left off with this example of an increase in price from $2 to $4 decreases quantity demanded from 100 to 60. We determined it's inelastic. So now what I want you guys to do is calculate the total revenue before and after the price change. So total revenue is just price times quantity. So it would be 2 times 100 equals 100. After the price change is 4, sorry, this is 200. 4 times 60 is 240. So, in this case, if total revenue is the only concern, should the company raise the price? And the answer is yes. So, we're heading toward our total revenue rules that says if a good is inelastic, if you raise the price, total revenue will increase, which kind of makes sense, right? Like you want to raise the price of cigarettes because people will smoke anyway. All right, let's go through this example here. Again, if I were you, I would pause and do it on your own. The increase of the price from $2 to $4 decreases quantity demanded from 100 to 40. Again, let's do a common sense check here. It's the same price increase as before with a bigger quantity demanded decrease. Price doubled and quantity demanded more than halved, so it is probably an elastic good. But let's calculate it. Actually, I have the formula right here. All right, so we're going to say this is P, oops, I need the pen feature. All right, anyway, so P1 again is 2, P2 is 4, Q1 is 100, Q2 40. All right, so let's calculate the elasticity. Percent change in quantity over percent change in price. We've got 40 minus 100 over the midpoint, which would be 70. The way that I get that is I do Q2 plus Q1 divided by 2, so that's 40 plus 100 divided by 2, which is 70, divided by, let's see here, this is 4 minus 2 over 3 again. We take the midpoint, 4 plus 2 divided by 3. So this is 60 over 70. Notice how I got sloppy with the negative sign? They're always negative, so sometimes we just forget about it. And then this again is 2/3. So let me use my calculator. I actually did have a student tell me, she's taking a class with a math professor, and she said, I prefer your way when you would take out your calculator, because it like slows it down and helps me to think through things. She's like, Professor Gong, the math professor, just does it in his head and it's too fast. So I will continue to use my calculator. All right, so I've got 1.27, actually 1.28 if I round correctly. So that is elastic. It's greater than 1, so it's elastic as we predicted. So total revenue before the price change is 2 times 100 equals 200, like before. And after the price change, it's 4 times 40, which was 160. Okay, so we increased the price and total revenue dropped, and that is true with an elastic good. So let's think about those red Ford minivans. You probably don't want to increase the price because people are going to respond in a very high way. All right, anyway, so this is our last one here. We've got an increase in a price from 50 cents to 35 cents, decreases the quantity demanded from 35 to 5. So really big increase in price, really big decrease in quantity demanded. It's kind of hard to do a common sense check on this. All right, so we've got P1. Where's my pen? P1 is 0.5, Q1 is 35, P2 is 3.5, Q2 is 5. All right, let's calculate the elasticity. So we've got percent change in quantity over percent change in price. This is going to be 5 minus 35 over over 20, I think. I'm going to use my calculator. All right. 5 plus 35 over 2. Yep, it's late in the day. I don't trust my brain. All right, and then in the denominator, we're going to have percent change in price, which is, let's see here, 3.5 minus 0.5 over 2. All right, so in the numerator, we've got 30 over 20. And in the denominator, we've got 3 over 2. And of course, this ends up being 1, because why would I bother if we didn't have a unit elastic example? So that's why it was kind of hard to do the common sense check. It's like, was that a big response? Wasn't it a big response? It's kind of hard to tell. That's because it's exactly proportional. So the percent change for both was about 67%. And so we've got, not 67, 150%. So we've got a unit elastic good. So let's come up with the total revenue before and after the price change. Before the price change, it was 0.5 times 35. After the price change, it was 3.5 times 5. And if I remember correctly, 0.5 times 3.5, that's, no, 0.5 times 35, that's 17.5. It's another tip, you guys. If you use the same example for like 8 years like I have, you can kind of do it quick. Oh yeah, that doesn't look right. All right, so the total revenue is the same, and that's kind of the whole point. When you've got a unit elastic good and you raise the price, your total revenue stays the same because it perfectly offsets. So moving on. So here's the total revenue. It says test, it's supposed to say rule. Well, actually, I think your book calls it a test. I call it a rule. When demand is elastic, if you increase the price, it leads to a decrease in total revenue. When demand is inelastic, if you increase the price, it leads to an increase in total revenue. And then when it's unit elastic, total revenue is actually maximized, or it doesn't change. So again, I like to think of my examples. A good that's very elastic, red Ford minivans. Maybe you put them on sale. Let's decrease the price. It's going to lead to an increase in total revenue from those. What about your cigarettes or your heroin or whatever addictive substance? Are you going to put it on sale? No, you're not going to put it on sale. You're not going to entice people to smoke cigarettes or use heroin because it's on sale. Why? That's an inelastic good. All right, so here's an example from your textbook. And what I'm going to use this for is to calculate the point elasticity. That's the one where we have a linear demand curve. But also I'm going to show you how price elasticity changes along a linear demand curve, which is always a really weird thing to see. So we've got our demand curve. It's equal to 80 minus 2px. Okay. So what I want us to do is calculate the point elasticity of demand, and let's just choose one and see if we can get the same one that it tells us. So let's choose point B. Okay. So the first part here, the slope. So this is the slope, and the slope of this line is 2. Okay, so the elasticity is going to be 2 times the price and quantity at whichever point we happen to care about. Price is 5, quantity is 70. So if you do this on your handy calculator, 5 divided by 70 times 2, I get 0.14. Look at that. See? So that's just, you know, a different way to calculate elasticity that some of you may teach or some of you may use. Now the other thing I want us to see in this example is how elasticity changes and how total revenue changes. So where is the elastic part of the curve? The elastic part of the curve is down here. Any elasticity that's greater than 1 is elastic. If you raise the price on an elastic good, total revenue should decrease. And you see that that happens. Let's look at the inelastic portion. That's the portion from here to here, under 1. If you raise the price on an inelastic good, total revenue should increase. There we go. And at this point here, where it's unit elastic, we've got total revenue being maximized. So if all we cared about was total revenue, textbook could end, right? We've got our solution. Always maximize your total revenue where price elasticity of demand is 1. Unfortunately, we've also got costs. Sometimes revenue is not our main concern. But anyway, so we can see this along the demand curve. And this is something I still can't do in my head. I always have to think, wait, which part's elastic and which part's inelastic? But if you think about it here, the inelastic part, it's the lower part of the price. So you're going to have high percent changes in price. And it's the higher part in quantity, so you're going to have lower percent changes in quantity. So that's inelastic. If what I said doesn't make sense, it's totally fine. Here, we've got the low quantities. The low quantities here, and so we're going to have higher percent change in quantity related to price, so that's elastic. And then this is something that's actually important, is the total revenue curve. If you put quantity here and you graph total revenue, you're going to see that it increases during the elastic portion and then decreases during the inelastic portion. Now, how do we wrap our heads around that? As we move right on the quantity, we're assuming prices are dropping, right? Because there's an inverse relationship between price and quantity together. So this is associated with a decrease in price, putting stuff on sale. So if you put your red Ford minivans on sale, your elastic goods, your revenue increases. We're going to hit a point, though, where it becomes elastic, and then total revenue is going to decrease. So this is, it's kind of the hard part, calculating it, wrapping our heads around what it means. This is the fun part of elasticity. So what affects the price elasticity of demand? 3 factors. Number 1, the availability and number of substitutes. Why do I keep using red Ford minivans? Because that's a way to have tons of substitutes. So let's think about unknown artists. So I've got these pictures behind me. It's some artist that's talented, obviously, but not super well known. Lots of substitutes for this person. If I want a map of San Francisco, which is what this is, there's many options for me, right? So if she raised her price, I'm not buying that. So more substitutes, more elastic. The second thing, and there is a tricky problem on your homework about this, time and the duration of purchase horizon. So in the short run, the price elasticity of demand tends to be very inelastic. Let's think about gasoline. We just had a terrible hurricane. We don't know what's going to happen to the price of gasoline. But let's say it goes up. So the price of gasoline goes up. I'm stuck buying that, right? I've got my car. I live in this house a certain distance from work. I have to buy it. In the long run, though, I might get a more fuel-efficient car. I might move closer to work, things like that. And then number 3, the expenditure share of consumers' budgets. If something is a big part of your budget, you care a lot about the price and it's elastic. An example would be foreign airline travel, rent, house prices, right? So my house price is supposed to be 30% of your income. I'm paying attention to that. Really, really small part of your income, so I don't know, see these scissors that I don't know why my husband has out? They're probably 50 cents. If this doubles in price, I don't care because it's still $1, right? So we tend to have inelastic demand for things that are very small proportion of your income. So I'm going to stop here because we're out of time on this recording. But I want you guys to test your understanding here and think about what is more inelastic for each of these goods.